Now this is going to start into understanding the performance dynamics of web-based applications. And this is important to know when you're developing your applications, how things like network latency and chattiness and packet loss and a variety of other metrics affect your application. And it's really important to know this as well for not only the development aspect, but also for troubleshooting. So I'm going to start here in this lecture with what causes a network latency. There's no other attribute that affects your application more than network latency. So it's the number one enemy for web page loads that are slow. So there's basically a variety of different components of network latency. So you can see here, the main culprit is propagation delay. And that really is distance from your web browser to the origin server. And it could be something within the data center to something halfway around the world. And that distance will have the biggest effect on your web page loading. And so it's really based on kind of a fixed formula that's around an average of 10 microseconds per mile average. So you just do the calculation over 2,000 miles, and that'll give you a standard delay in one direction. And then you have to multiply by 2 for round trip. And it's really based on, like I said, the distance. So propagation delay is the main culprit there. Then there's transmission delay. And this idea here is that anytime you're putting bits on the wire, as we talked about serialization at the physical layer, what happens is that takes time to put them on the wire, each one. And that's what transmission delay is, just the time to put the bits on the wire. And it's really a function of the network interface speed and packet size. So if you have a fast interface like 10 gig and you have a small packet of, say, 64 bytes, it's going to be basically negligible how much transmission delay. It's going to be fast. But if you've got, say, a 10 meg interface, 10 megabits per second, and you're using long packet, full packets, it's going to make a big difference. The thing with transmission delay is it's only one component of network latency. So this idea that you can increase bandwidth and fix all your problems will slowly be dissipated. You'll realize just how that doesn't work because there's so many other factors involved. Transmission delay is only one of them. And increasing bandwidth will help. But if you have bottlenecks around, or if you have queuing delay, propagation delay, it doesn't matter how much bandwidth you have. At some point, you're going to run into other problems with the other components. So you'll find that bandwidth is only one solution, but it's really only part of a full solution. Then there's device processing delay, and that happens at devices like switches, routers, and firewalls, for example. And that's just the different aspects of packets arriving at the device, and then doing routing table lookups, rewriting packets, adding QoS, doing filtering of access control lists. Really a variety of different things that happen on each device that will slow it down. You'll actually have delay doing that. And the busier the device is, the worse it gets. Then there's queuing delay, and that's just packets waiting in the hardware and software queues. Software queues mean QoS. Hardware queues are just standard with the devices that you get that have nothing to do with QoS. So the queuing delay will just be standard if the device is busy or the circuit is busy. You'll have queuing delays that just happen as a part of trying to get the packets onto the wire. Then there's protocol delay, and that's something that's involved with things like TCP flow control, retransmissions of packets, DNS lookups, and TLS handshakes. All handshakes are part of protocol delay, but specifically DNS lookups at the beginning of a session could be considered protocol delay as well. So the network latency itself is just cumulative delays from source to destination. That's how we would describe it. So propagation delay effects. So I added something on propagation delay since it's just, it's one of the things that contributes most to problems with the performance of your web-based application. It's propagation delay. The reason why CDNs are so popular. I've got client to server, and I'm showing one-way latency of 20 milliseconds, and that's actually kind of fast. So I've got last mile copper from the client to the service provider. So this is just the local loop. So from, it could be your home to your central office, ISP, where you're getting your service, or it could be the data center to whatever service the data center is using. The last mile is what is called but I've got copper here just to show that there's different types of media. Then from the ISP, then you're into the ISP network, and there's just a variety of things that can increase propagation delay there, a lot of things. The number of hops, that's based on distance, but sometimes if you have routing problems, you'll have ISPs take you through 5 or 6 hops and only should take 1 or 2 hops. And all of that, as you're going through these devices, is adding up latency, because if the devices are overloaded, you're going to have device processing delays and queuing delays. The ISP could be congested at certain points if it's a complex network. And then, like I said, with the node congestion and ISP congestion, it really adds up if you have an ISP that's not doing the routing efficiently. So yeah, those are the things that you want to consider. The last mile telco loop is famous for just being adding to the latency disproportionately. You have line quality issues always in the local loop. There's also protocol handoffs to the service provider. I've added wireless contention since wireless is used so much. And wireless, I'll talk about all the problems with wireless that can happen in the last mile as well. And over here, I've got last mile fiber, so that just showed you can have different last mile media. And the other thing to keep in mind is extended pings are a good testing tool to use. You can customize it with different packet sizes to do testing and packet count. And I'll do that in the lab. I'll show you how to do that.